Hi, in this video I want to go over how we find the mean and standard deviation of raw and grouped data. For the purposes of this discussion, we'll be treating the data as a population. First, we start with raw data. So here's an example. It has to do with thorax lengths of fruit flies. So here we have these values measured in millimeters. How do we find the mean and standard deviation of these values here? Well, to find the mean of these values, we simply add up the values we have here. That's what this is saying here. And then we divide by how many we have. To find the standard deviation for each one of these values, we find the corresponding deviation score. Recall that the deviation score is the difference between the value and the mean. So obviously, to find the standard deviation, we have to find the mean of the data first. So what we have here actually is the variance, and the standard deviation is going to be the square root of this variance. So this is saying add up all the squared deviations. You find for each one of these values, you find the deviation squared, and then you add them all up. And so you have that sum, and then you divide it again by how many you have. Note that what we're finding here when we find the variance is essentially the average of the square deviation. And then of course you square root that variance to get the standard deviation. Remember that the standard deviation is a measure of spread. It is a measure of how much variation there is in your data. Let's find the mean and standard deviation of this data using Excel. Here I have the values, and what I want to do is count how many I have. So I have this little function here. I'm counting the values from B2 to B12. And of course, I have 11 of them. I also need to add them up. And of course, then that's a sum from B2 to B12. So be careful that you don't include B13 in this formula here. And then, of course, finding the average is simply a matter of dividing the sum of those values, referring to B14, the sum of those values divided by how many you have. All right, and you get the answer here. Be careful that you don't write 8.88 here and 11 here. It's true that those are the values, but you should always keep referencing is actually the word. You should always keep referencing the cell and whatever value is in there. The only thing that should be hard-coded here are your original values. Of course, you could also find the average by simply saying equal average, and then just giving it these values. So the point here, oh, by the way, if you see this discrepancy, it's just because of the number of decimal places we're showing. All right, so I could show, Excel keeps many decimal places stored internally, but I'm just keeping this at 4 decimal places. What else can I say here? So yes, when you're doing your work and you have to find the average, you won't go through all of this. But I just want to make sure that you understand, what's going on here. So that when you use a function, you have a sense of what it is that the software is doing for you. All right, so let's look now at how we find the standard deviation. To find the standard deviation of these values here, it's as simple as saying STD, and of course then we have P and S to choose from. We'll pick P because it's a population, and then it's just these values right here, and we get 0.0896. However, let's look at this in a little bit more detail. So the standard deviation, which I'll place that value here, is going to somewhere here, is going to be the square root of the variance. So let's focus first on finding the variance. And the variance is an average. It's an average of the square deviations. So I need to find those square deviations. So here I find the square of the deviation associated with 0.72. So look at it, it's 0.72 minus the mean, and then I square it. As simple as that. Note here that the reference to this cell is an absolute reference. I'm going to copy these values down, and I want in every case this cell to be referenced in the subtraction. And another thing here, notice we get all these values here. Let's just keep it to 4 decimal places. And let's center that more or less. I don't need so much space, so let's make this a little bit smaller. Let's center this. So this is just making it look half decent. All right. And so now we just drag this down. I had to move this out of the way because for some reason when I dragged this down, it was copying this expression also. And it made it look very, very ugly. Okay, so I have notice in each case I have the difference between this value and the mean, and then I'm squaring it. So I want to get the sum of those values and then divide it by how many I have. So that will give me here the variance. I could simply say the average of these values, but let's not do that. By the way, instead of placing this here, let's place it here. So we don't think that it's the count, it's the sum, obviously. And it's the sum of these values, and then I want to get the average, and so the average of these values. I have an average symbol here, but this is the average of these values, so don't ever use this symbol for the average of these because it would be wrong. This symbol is the average of your population. These values here are not your population, right? All right, so let's find the average of these values here. So it's going to be equal to the sum of those square deviations divided by how many we have. And we know we have 11 of these values. This gives us the variance, and now the standard deviation is simply the square root of our variance. And there we have it. We can keep these to 4 decimal place. And there we have it. We get the same thing. So I really want you to do this at least once, going through all of this to reinforce the idea of what it is that you're doing when you find the variance and the standard deviation. No, it would make no sense for me to teach this course by simply saying, oh, the standard deviation is what you get when you type this and you have some numbers. That really would not cut it at all, and I hope you appreciate that. Okay, so let's look at group data now. Now we turn our attention to finding the mean and standard deviation of group data. So here is an example here, right? I want to find the mean of the values, but I don't have the original values anymore. Note if I had the values, I simply add them up and divide by how many I have. But what I have here is a summary. What I can get from this summary is the exact number of values, because notice for each class we have the frequency, which is the count of values in that class. And so to get the number of values in our data set, I simply add up these frequencies. But how do I get the sum of the values in my data set? Well, I have to estimate it. What I'm going to say is that, well, I'm going to find the midpoint of the class, and I'm going to say, well, every value in the class is 43.5, for example, in this case. And so if I want the sum of the values in this class, or if I'm going to estimate it, I just say 25 times 43.5, and that gives me an estimation of the sum of all the values in that class. Likewise here, I say, well, every single value in this class is 47.5. If I multiply that by 14, I get the sum of all the values in that class. So I can record those products here. So if you notice, I have f times xm. So here it will be 25 times, and xm here is 43.5, here it's 47.5, and so on. So I get those products. And of course, if I add them all up, I get the sum of all the values in my data set, an estimation of the sum of all the values in my data set. And then I simply divide by how many I have. So I hope you see that the idea, the definition of the mean, by using this approach, we keep that idea alive. There are other ways of doing this, and for some reason students tend to find this confusing, but if you work at it and you see the sense of it, then I think it's better, right? Because to the degree that it's possible, you should use equations that reflect some idea, some concept. Moving on to the variance, because then we're going to use this to get the standard deviation. I want you to be able to see that here we're keeping the idea alive again. Right? Remember, it's going to be, for a data set, the variance is simply what? The average of the square deviations. So what we're going to do is add up all the square deviations and then divide by how many we have. So we already know how many values we have. It's the sum of these frequencies. But how do I get the sum of the square deviations? Well, it's the same trick as we're going to be using here, the same estimation. We're going to say that every single value here is 43.5, let's say. Remember, I have already determined a mean. It's an estimation, but that's the mean we'll be working with. So the deviation score associated with 43.5 is 43.5 minus whatever mean I got. And since every value in here is 43.5, that's the assumption we're making, that's the approximation we're making, well, then all I have to do is say, well, 25 times the square of that deviation. In other words, I'm going to say what? 43.5 minus whatever mean I got, and then square that difference and multiply it by 25. And that will give me the sum of all the square deviations in this class. Of course, again, I need a column for that. And once I have done that for every single one of these classes, then for every single class, I will have what? The sum of the squared deviations. So this expression here, I hope you can look at it and see what it is saying. The point is mathematical literacy. You can see what it's saying. It's the sum of those square deviations for each class, and then we're adding it up. So this gives me f times this gives me the sum of the square deviations for a particular class, and then here I'm adding them all up and then dividing by how many I have. Okay, so let's see how we do this in Excel. Here is our frequency table. We have the classes. For each class, the lowest speed, the highest speed in each class. And here we have the number of values in each class. So there are 25 values between 42 and 45 inclusive. Now, how do we find the mean? What we want to do is add up all the values and divide by how many we have. So we want to add up all the values in here and then all the values in here and add them up. The problem is we don't know the actual values in this class here. So we're going to make an approximation. We're going to say that the 25 values in this class, well, that they are all 43.5. And so when I multiply 25 by 43.5, this gives me an approximate sum of all the values in this class. Likewise here, we get the sum of all the values in this class by multiplying 14 by 47.5. So look at the little formulas here. Of course, when I have all of these values, then I add them up. And so this is the sum of all these values here. This gives me an approximation of the sum of all the data values that I have, or that I had, or that were used to create this frequency table. All that is left now is to divide this value by the sum of these counts, which is 50. And that's what we have here. Notice it's this divided by this. And that gives us the mean of our data set, or an approximation, I should say, of the mean of our data set. Now we find the standard deviation of our frequency distribution. As you know, the standard deviation is the square root of the variance, so we'll focus on finding the variance. Remember, the variance is, or can be conceived of as an average, the average of the square deviations. So what I would like to do is take all the values in my data set, find the square deviations, add them up and divide by how many I have. The problem is I don't have the original values in the data set. So we do the same thing here. We're going to assume that the 25 values in this class, well, that the 25 values are all 43.5. And so to get the sum of all the squared, to get the sum of all the square deviations for that class, for this class here, well, I just need to multiply the square deviation for this value by 25. So what is the squared deviation for this value here? Well, notice I just simply say I'm 43.5 minus the mean here, which is 46.78, and then I square it. Note that we're using an absolute reference here, so that when I copy this down, well, every one of these cells references this in the formula. And that's it. All right. This is the square deviation associated with 43.5. And then I want the sum of all those square deviations. Well, I simply multiply this by 25 because we're saying that they're all the same. Remember, this is an approximation. We don't have the original values. And so that is what I have here. Notice I simply multiply the square deviation associated with 43.5 by how many I have, 25. And that's it. And then now all that is left to do is add these values here. And that's simply the sum of those values. And then to get the average square deviation, I just take this sum here and divide it by how many values I have. And so I divide this by 50. Notice I'm using cell references. I'm not hard coding the values. This gives me my variance, and of course then this gives me it's the square root of this. I get the standard deviation. So this covers a fairly in-depth look at how you go about calculating the mean and standard deviation for raw data and group data. Bear in mind that yes, there is software here that can do all of this for you without having to do any of this work. Even Excel has very powerful tools that would allow you to calculate these values without having to go through all of this. So this exercise is an educational exercise, right? It's aimed at having you have a deeper understanding of the mean and the standard deviation, and understand what's going on when they're calculated with raw data and with group data. Okay, so that's it. Bye.